Okay, class, today we're in section 5.5 extension, graph absolute value functions. The goal in this lesson is to graph absolute value functions. The function f of x is equal to the absolute value of x is an example of an absolute value function and is the parent function for all absolute value functions. You can graph absolute value functions by using a table of values as shown below for f of x is equal to the absolute value of x. Key concept: graph a parent function for absolute value functions. The domain of the parent absolute value function is all real numbers. The range is y is greater than or equal to 0. The graph consists of two rays. That's one ray, that's the other ray, with a common endpoint called the vertex. So right here is your vertex at 0, 0. The minimum value of the function occurs at the vertex. So the minimum value occurs right here. That's like saying that's the lowest value. Notice that you have 0, you have positive values for x, and you have negative values for x. That's important when it's time to graph. Now let's take a look at example 1. Graph g of x is equal to the absolute value of x minus h, and g of x is equal to the absolute value of x plus k. Graph each function. Compare the graph with the graph of f of x is equal to the absolute value of x. A. G of x is equal to the absolute value of x minus 2. Step 1. Make a table of values. Here, they give us the values of 0, 1, 2, 3, and 4. However, you can make your own values when you are told to do so. And when you make your own values, remember you want to pick both positive and negative numbers. Positive and negative numbers. The most common numbers to pick would be like over here. 0, 1, 2, negative 1, negative 2. Once again, the most common numbers to pick would be 0, negative 1, negative 2, and then positive 1 and positive 2. But back on to step 1 in the first example of part A. Here, when x is 0, I'll take x and plug it into my absolute value equation. So here I will end up with 0 minus 2. What is 0 minus 2? A negative 2. What's the absolute value of a negative 2? 2. Next, I will put 1 in. 1 minus 2, that would be a negative 1. What's the absolute value of a negative 1? Positive 1. Next, I will put 2 in. 2 minus 2 is 0. Absolute value of 0 is 0. Next will be 3. 3 minus 2 is 1. The absolute value of 1 is 1. Next will be 4. 4 minus 2 is 2. The absolute value of 2 is 2. After finding the values, then I go to step 2 and I'm going to graph the function. So I graph each function. So first I graph my x, then my y, xy, 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 xy as an ordered pair. After doing so, this is what my graph looks like. Now the blue is the original f of x is equal to the absolute value of x. The red is my new graph based on this table. G of x is equal to x, absolute value of x minus 2. Step 3 says to compare the graphs of g and f. The graph of g of x is equal to the absolute value of x minus 2 is 2 units to the right of the graph of f of x is equal to the absolute value of x. In other words, that's a fancy way of saying that the graph shifts 2 units to the right. Notice I had a negative 2 in the absolute value sign. Even though it's negative, it shifts in a positive direction 2 units. If this 2 were positive, it would have shifted in the negative direction. So it's behaving just the opposite of what we think it would be. Okay, now for B, g of x is equal to the absolute value of x minus 1. First, notice that the -1 is on the outside of the absolute value sign, as opposed to being on the inside of the absolute value sign in the first example. Step 1, same process. Make a table of values. 0, -1, -2, and then +1 and +2. G of x is equal to 1, 0, -1, 0, 1. How do we get those values? We plug in. Absolute value of a -2 is a +2. So 2 minus 1 is 1. Absolute value of a -1 is a +1. 1 minus 1, 0. Absolute value of 0 is 0. 0 minus 1, -1. Absolute value of 1 is 1. 1 minus 1 gives us 0. And then the absolute value of 2 is 2. And then 2 minus 1 is 1. After making our table, we graph. Now, when we graph here, notice what happens here. This is our original graph of the absolute value of x in blue. This is our new graph in red. Notice that it went down 1 unit. It went down 1 unit. That is, every point goes down 1 unit. So when we compare the graphs of g and f, the graph of g of x equal to the absolute value of x minus 1 is 1 unit below the graph of f of x is equal to x. All right, to make it really simple, all we're saying is that when you have the absolute value sign and it's being subtracted by a number or whatever number's on the outside, it's going to control if it goes up or down. If it's negative, it's going to shift it down, vertical. If it's positive, it's going to shift it up. Over here, when our number is on the inside of the absolute value sign, it will make it go either to the left or to the right. And it's going to behave just the opposite that we think it would behave. If it's negative, it's going to shift in a positive direction 2 units. If it's positive, it would have ended up shifting in the negative direction 2 units. Okay, next we have example 2. Graph g of x is equal to a times the absolute value of x. Graph each function, compare the graph with the graph of f of x is equal to the absolute value of x. A. Graph g of x is equal to 4 times the absolute value of x. Step 1. Make a table of values. Once again, we pick 0, -1, 2, and then 1 and 2. So we have a negative, positive, and we have 0. We plug into our equation, and then we find our values. All right, just to look at a couple of them. When x is a -2, I will put in the absolute value of -2. Absolute value of -2 is a +2. 4 times 2 is 8. I'll put in -1. Absolute value of a -1 is a +1. 4 times 1 is 4. Put in 0. Absolute value of 0 is 0. 4 times 0 will give me 0. Put in 1. Absolute value of 1 is 1. 4 times 1 is 4. Put in 2. Absolute value of 2 is 2. And then 4 times 2 will give me 8. Then I will plot my graph. After plotting, I should make the following comparison. Compare the graphs of g and f. The graph of g of x is equal to 4x opens up and is narrower than the graph of f of x is equal to the absolute value of x. Here is absolute value of x, and here is g of x is equal to 4x. I'm noticing that because my 4 is positive, it makes the graph open upward. Also, I'm noticing that the larger this number is, the more narrow my graph is. The larger this number is, the more narrow my graph is. Notice that for f of x is equal to the absolute value of x, there's a 1 sitting on the outside. So I'm comparing the 1 to the 4. All right. Once again, there is a 1 that is on the outside there that we don't see, but we know it's there because it's implied. So 1 and 4. And I'm noticing that the bigger this number is, the smaller my absolute value function would be. All right, and to bring this out even more, let's go over to the next example. Let's look at B. All right, now looking at B, I notice that my g of x is being multiplied by a negative 0.5. A negative 0.5. Step one, I'm going to make my table of values. And when I do that, I get 0. In this case, they're using 0, negative 2, negative 4. And then they're using 2 and 4. Notice they picked numbers that were easy to work with when we're multiplying by 0.5. Because 0.5 is like saying you're multiplying by a half. So you want to pick numbers that are easily multiplied or divisible by 2. And that will be even numbers. Okay, so when we plug in, when I plug in a negative 4, I get the absolute value of a negative 4. That's going to be a positive 4. Then I get a positive 4 times a negative 0.5 or times 1/2. And that's going to give me a negative 2. Now I plug in negative 2. Absolute value of a negative 2 is a positive 2. I'm multiplying that by negative 0.5, so it's going to give me a negative 1. Next, I put in 0. Absolute value of 0 is 0. A negative 0.5 times 0 will give me 0. Next, I put in 2. The absolute value of 2 is 2. And then 2 multiplied by a negative 0.5 will give me a negative 1. Next, I got the absolute value of 4. Absolute value of 4 is 4. After being multiplied by a negative 0.5, I come out with a negative 2. Then I make my graph. And notice, look how wide this graph is when compared to just the f of x. Look how wide this graph is when compared to the f of x. Also notice that this graph is flipped, that is, it's upside down. Why is it upside down? Because my value in front of the x was negative. In front of the absolute value of x was negative. So therefore it makes it flip. And the smaller the number, the wider the graph. The smaller the number, the wider the graph. All right, to read that, compare the graphs of g and f. The graph of g of x is equal to a negative 0.5 times the absolute value of x opens down and is wider than the graph of f of x. All right, now, key concepts. Comparing graphs of absolute value functions with the graph of f of x is equal to the absolute value of x. G of x is equal to the absolute value of x minus x means that x, if h is greater than 0, the graph of g is the absolute value of g. Units to the right of the graph of f of x is equal to the absolute value of x. If h is less than 0, the graph of g is absolute value of h units to the left of the graph of f of x is equal to the absolute value of x. A fancy way of saying is if this is negative, it's going to move in a positive direction. If it's positive, it's going to move in the negative direction. Here, all this is saying is g of x is equal to the absolute value of x plus k. If this is positive, it's going to shift up that many units. If it's negative, it's going to shift down. Here, g of x is equal to a times the absolute value of x. All this is saying is if it's positive, it's going to open upward. If it's negative, it's going to open downward. All right, once again, if it's positive, it will open upward. If it's negative, it will open downward. Next, the bigger this value, the more narrow. The bigger the value, the more narrow. The smaller the value, the bigger this number, the more narrow. The smaller, the more wider. All right, and once again, to read that, if the absolute value of a is greater than 1, the graph of g is narrower than the graph of g of f of x. Let me start that again. If the absolute value of a is greater than 1, the graph of G is narrower